Hey Dragons, on day one of quadratics, we looked at all the equations that were in this form right here, x squared plus k. And we noticed that k translated it either up or down. Today we're going to dig a little deeper and we're going to introduce the form of the equation that includes h. Now, to refresh your memory, the first day we talked about h and k as being the nickname letters or the new letters that would describe the vertex of the parabola. The vertex, again, is the point where it changes direction. It's either the low minimum point in a parabola that opens upward, or it's going to be a maximum high point for a parabola that opens downward. Okay? So, when we do these first couple of problems together, okay, have your calculator, fill in everything that I fill in, and I want you to be paying attention to this right here and see how it affects the parent parabola. Now, the instruction today, you only have to draw the quadratic parent on the first three problems, okay? If it helps you out, I would suggest that you do it on all your problems, okay? Now remember, the parent is the most basic. It's f of x is equal to x squared, okay? And here is my sketch of this already. So we're going to now come over here and we're going to notice over here I've got x minus a number, and all of that is squared, and then I have a plus a number. So this problem fits this form perfectly because I have minus signs right here and I got a plus sign right here. So if I look at this form or copy it again, x minus h quantity squared plus k, because these signs are exactly what I want, I can gather right now that h is 2 and k is 1. Well, if h is 2 and k is 1, guess what I just found by looking at this problem? I found the vertex. So I'm going to put a 2, remember that's my h, and I'm going to put a 1 right here, that's my k. Just like the first day, hk for the vertex. Now, let's prove this. Let's go back, let's take our calculator. Let's type this in as we see it. And let's go to our table and fill it in. Now you notice that this, I don't have the same type of symmetry because we're going to, well, you'll see. Alright, let's come over here and let's see, a -1 input gives me an output of 10. Just going to copy. An input of 0 gives me an output of 5, and so on and so forth. 2, 1, 2, 5, 10. Now you can also see the symmetry in the table. I got a couple of 2s, a couple of 5s, a couple of 10s, and they're all surrounding this. 2, 1. Oh, that's my vertex. Just like the formula told us. Isn't that neat? So, if we come over here and we now, we can press graph, we can see, if we do a zoom 6, we can see what happens. At least hopefully we can. Well, my calculator froze up, so let's skip that and let's go over here and just do it by hand. I've got a -1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What else do I have? I have 0, 5. You know what that point's going to be called? I hope you do. I've got 1, 2. I've got 2, 1. I've got 3, 2. I've got 4, 5. And I've got 5, 10. So if I make my nice smooth curve, I can now compare the problem in blue to the parent. Now, from day one, K moved it up or down, and as you can see, the vertex went up 1 unit. So my K from day one is still valid. It went up because I have a plus. It went up 1 unit. So I have a translation of going up 1. But you also notice that I have a shift of my line of symmetry. In the parent it was right here, but now my line of symmetry for the blue guy has shifted to the right. So now if I fold the blue guy on this green dotted line of symmetry, I'm going to have two sides of the parabola lie exactly on top of each other. So here is my vertex. What point is that? It's 2, 1. Now you remember at the very beginning, because it was in that vertex form, I was able to identify H and K, which is the nickname for the vertex. We have verified that. So if we look at our graph, it's a valley, it's a low point, it is a minimum. Okay. Now, do I have any zeros? Do you remember what zeros are? I hope you do. Remember, the zeros are x-intercepts. Does the blue parabola cross the x-axis? I hope you look at this and say no. So I don't have any zeros. None, or not applicable, whatever. Do I have a y-intercept? Absolutely, right there. That's where it crosses the y-axis. You could also tell from your table. Remember, when you have a 0 as an input, that is going to be on the y-axis, so I have 0, 5. Now, do you notice the difference between day 2 and day 1? On day 1, these two things, the vertex and the y-intercept, were the same. That was because my line of symmetry was x equals 0. Now that is no longer the case. It has shifted to the right. So don't be freaked out by the fact that these aren't the same answers like they were on day 1. Okay? Now, my vertex, remember your vertex goes with your line of symmetry. X from the vertex is a 2, so I have x equals 2. Can we verify that with our picture? Look at my vertical line. It's crossing the x-axis at 2. It's a vertical Hoivux. My equation for my line of symmetry is going to be x equals 2. Remember, the vertex and the line of symmetry go together. What is the value of k? Well, I kind of did that at the very beginning. The value of k is 1. What is the value of h? Up here, the value of h was 2. Could have looked over here as well. And describe the transformation. Well, again, if we look at our picture, starting with the red parent, all right, so look at the vertex. The vertex slid up and then to the right. Slid up 1 and then translated to the right. These two parabolas are still of the same size. Then one is not wider than the other. So we can say that we translate, we went up 1 unit, again that's your k, and then we went to the right 2 units, that's my h. If we look at our domain, if you're in my class, remember the domain for any parabola with arrows, and these have arrows, it's going to be negative infinity is less than x is less than positive infinity. Every parabola. So let's look at the range. I have a minimum point of what? Minimum point y value is a 1, and then everything else goes above it. So I have y that is greater than or equal to 1 for my range. And the other way I could do that is say that my low value is 1. I do touch that. And then y is continuing on upward forever. So either one of these two is correct. Okay? So let's look at another one. Make sure that you have all of this filled in before you move on to the next one. All right, problem number 2. Have you drawn in the quadratic parent, x squared? Again, if you don't remember how to do that, go to your calculator and just type in your x squared and get some values right there and plug them in. Okay? Now, if you take a look at this problem and compare it to our form, it's a little different. You notice that in the form that we're given, it's minus h and plus k. Well, over here, I've got a plus inside the parentheses, so that's a little different. And then I have a minus here. This shouldn't be a big deal. All right? Minus 3, translation from day 1. This is going to slide it down 3. Okay? But what we can do is we can just take our calculator and let's fill in the table. So I'm going to do parentheses x plus 1, close it, and we're going to square that quantity. We're going to square what's inside the parentheses, and then we're going to subtract 3. So let's go to our table, and our first value input is a -4. That gives me an output of 6. -3 gives me an output of 1. -2 gives me a -2. -1 gives me a -3. -2, 1, and 6. Straight from the table of values. Okay? So let's go over here and let's graph this bad boy. We've got -4, 6. And we've got -3, 1. We've got -2, 2. -1, -3. We've got 0, -2. I've got 1, 1, so I'm going to share that point with the parent. And I've got 2, 6. So now, if we graph this very carefully, what happened? From red to, I don't know, what color is this? Light blue. Doesn't look light blue on the paper. All right, so again, when you look at the translation, why don't you just focus on the vertex. The vertex was here at 0, 0, and now it's here at -1, -3. So let's just write that down. That's just by observation. -1, -3. So my h is going to be a -1 and my k is going to be a -3. Okay, so as I take a look back up here, my form says quantity x minus h squared. Okay, so how did I look at this right here and get a -1 out of that? Well, again, my form requires a minus sign. And if you want to add something using a minus sign, you're going to have to subtract its opposite. So that's a little weird right there, but you're just going to have to deal with it. Okay? So if I put x plus 1 and I rewrite it using a minus sign, it's really x minus a negative 1. So in this case, that's where I get an h of a negative 1. Okay, be careful on that. Rewrite. If you don't have a minus sign in your problem, you need to rewrite it so that you can see it, or you can just go with it right here. I mean, it really doesn't matter. And your k is going to be, well, that's going to be a negative, actually, same thing. How do I subtract 3 using a plus sign? Well, I'm going to add a negative 3. And you can see that's where I get k from. All right, that's neither here nor there. All right, how about my y-intercept? Is my y-intercept? Yep, it's right there. My y-intercept is going to be in negative 2. So 0, negative 2. And I just do that by observation, or I can take it from my table, either one. My line of symmetry, well, what's my vertex? My vertex is that, so steal the input, steal the first number, it's going to be x equals negative 1. Go verify it. If I come over here and slice and dice this guy right here, where does this line of symmetry for the blue